dy dt equals ky. Find the solution to the differential equation if k equals negative 0.5 and y sub 0 or y of 0 equals 200, and then we'll have a second problem. Now recall we have dy dt equals ky. Let's just deal with that one first. This one should look familiar, but I think it'd be a good thing. We need to know this, and we need to understand how to derive what y equals. So we're going to do separate the variables, get all the y's on the left here, and then all the constant, and then the dt on the right side. The antiderivative of dy over L of y is ln of absolute value of y equals kt plus some constant c. Raise both sides to the power of e, so we have e to the kt. We're going to need a c1 on that. So we'll have e to the c1 times e to the kt, and let's take off the absolute value, so we'll get y equals plus or minus. At this point, we will say let c equals plus or minus e to the c1, and we get y equals c e to the kt. And as you recall, when we have our initial value of y sub 0 or y of 0 equals y sub 0, we get y sub 0 equals c e to the 0, or in other words, c equals y sub 0, and we get the equation y equals y sub 0 e to the kt, which is our standard PERT equation. Go ahead, write that down. Make sure you know how to do this. We will see a harder version of this coming up soon. And if this part doesn't make sense, the harder one will be extremely difficult. So now, as far as number 1 goes, we have y sub 0 equals 200. Well, what is that? That is our initial value. Actually, I think I said y sub 0 again is y of 0 equals 200, but that's the same thing. Y sub 0, so we get this equation, y equals 200 times e to the negative 0.5 t. And we're done. Let's take a look at the next one. We know we just derived, we have y equals y sub 0 e to the kt. We're given our initial value here, so we're going to get y equals 80 e to the kt. We have a point here. We can plug in 40 equals 80 times e to the 10k. We could divide by the 80 and we get 1/2 e to the 10k. Now there's many ways you can go about it. What most people do is they'll take the ln of both sides and then divide by 10. But there's another way. What are we trying to find? We're trying to find this equation here. What if we, instead of looking at it e to the 10k, we did it as e to the k to the 10. So in other words, we have 1/2 equals e to the k to the 10. How can we solve for e to the k? We could raise both sides to the power of 1 over 10. And let me box this part here. Probably should have put it on the side. That's all we need. We can go back to our equation. We have 80 e to the k to the t, so this would be y equals 80. Instead of e to the k, we'll have 1/2 to the 1 over 10, and we will raise that to the power of t. Now what I'd like you to do right now is take a look closely at what this is. And really it would be beneficial for you to hit pause to think about, what is this equation? Have you ever seen this equation before? What is it? What is it familiar to you? Okay, hopefully you did pause it. This should look an awful lot like a half-life problem. this would say our half-life is 10, whatever units that is, we don't know in this particular problem. And so recall our half-life would be something like a to the 0 times 1/2 to the t over k. And that would be equal to something like a of t. Even though we approached it in a different way, we still got that same thing. If we look at our original, we have y of 0 equals 80 in 10 time units, let's say. It's half of that. Now let's take a look at a couple other problems. So for these two problems, let me zoom out a little bit so we can read the whole thing. Okay. For an investment with interest compounded continuously, this for both 3 and 4, a $500 investment takes 12 years to double. Find the annual rate. Well, what would that be? It's doubling, so we would have 1,000. Our initial amount is 500 times e to the r times 12. So we just need to solve that. We get 2 equals e to the 12r. Take the ln of both sides. ln of 2 equals 12r, so r equals the 1/12 of ln of 2. And then we can take out our calculator. See if I can get that to show up a little bit. There's a little bit. So we can say ln of 2 divided by 12. Hit enter. And we get r equals 0.0578, let's say. Now, this is our percentage written as a decimal. So convert it to a percent, we would have approximately 5.78%, which would be our rate. Now let's look how much is in the account after 30 years. At that point, we would have something like a of 30 equals 500 times 1/2, actually sorry, not 1/2 in this case, we're talking about doubling, but it's just like the half-life problem. 2 to the 1/12, and then we're going to raise that to our power of t, and in this case that is 30. At this point you just need to type it in on your calculator, and you get 28.43 dollars. If we didn't have our calculator, we would simplify 30 over 12 and get 2.5, and we could then say that the 2 squared and then 2 to the 1/2 power, and we could simplify like that. But since we have our calculator, we just type it in.